Okay, I start recording our session. Okay, and I'm sharing my screen with you. Okay, now today we will cover this chapter on normal distribution, and I will add the distribution called exponential distribution. Okay. Last week we talked about the discrete probability distribution, and can you see my screen now?
I still cannot see it.
Let me see. Why? Oh, I didn't hit share. Okay. How about now?
Yep, I can see it.
Okay, good. Okay, so I will cover the two most commonly used probability distribution. One is normal distribution. The other is exponential distribution. And then I will spend like maybe 20 at most 30 minutes and to cover this part. Then we'll cover the assignment. Okay, it should take less than an hour, 40 minutes to an hour. Okay, so we talked about normal distribution and what is a normal distribution? What kind of properties do we have? Number one is the density curve is always on or above the horizontal axis. Okay, and then the total area under the curve is equal to 1. Okay, above the horizontal axis means the probability is always positive. It's always positive. Okay, let me see. Yeah. Okay, and then this is okay. Well, this doesn't look like normal distribution. It's any distribution, any arbitrary, any distribution that can be called a probability distribution. It must have a total area 1 under the curve. If the area under the curve is not 1, then it's not qualified to be called a probability distribution. So we see variable and the density curve. Density curve is the curve that that show the probability. Density is a kind of probability. So the density curve will tell you how much probability it has given the value. Okay, given the value. Let me see. Okay, 1 second. Let me. Are you able to mute your microphone? So there's some background noise. So if you mute your microphone for now, that will.
Okay.
Okay. Thank you. Okay. Yeah, but turn it on any time when you need to speak. Okay.
Okay.
Yeah. Okay. Thank you. Yeah. All right. So let me see right here. Okay. So and variable and the density curve. So that's what I just mentioned. That for a variable with density curve, the percentage of all possible observations of that variable lie within any specified range equals the corresponding area under the curve. In other words, the probability is equal to the area. Okay, and the next slide, this one, we shall see that to calculate the probability that a random variable is less than or equal to C, will be equal to the area to the left of C, okay, under the curve. So in this case, calculating probability is equal to calculating the area under the curve. And so this type of question is like doing the calculus problem in calculus if you have taken calculus before. Okay, and then it's just a matter of calculating from where to where. The first one is calculating integrating. So the first one is to integrate from lower bound to the point of C. The B here is to find the area. Then you integrate from D to upper bound under the curve. Okay, and then this is integrate between A and B. Okay, and following the function of the curve. And now normal distributed variable is one of the special curve that give you bell shape. Okay. Okay. Let's see. Okay. Normal curve. Okay. So sometimes we can use the normal curve to approximate the discrete probability distributions. Okay. So you see in the background is it's bars, but when we can impose a curve to approximate it, and you can see there are triangles cut up, but there are triangles included, so that makes up the squares, and in this sense we can say that a curve can pretty well approximate the bars. Okay, and here we see a normal curve with mean and sigma. These are the parameters of the normal distribution function, because in the normal distribution function we have parameters, and mu is the parameter, sigma also is another parameter, and these two parameters appears in the function in the normal distribution curve, which is a little bit messy. Okay. If you okay, it doesn't show the function, but it's it's 1 over square root of 2 pi sigma times e to the power of negative, then the ratio of in the numerator is with the parenthesis x minus mu to the square, okay, and then divided by 2 sigma square. Okay, so this is a normal distribution curve. Then normal distributed variable and the normal curve area is to calculate. So our goal here is to calculate the area under the curve. That's it. But to calculate area under the curve is not an easy task. If you are to do it with the function and then handling the calculus related to that integration. Okay, so what we do is either we use table or we use software like Excel can do the job, or R, or yeah, or some software. I will show you one. Okay. Okay, so and here we see that Z is we call it standardized version of the normal distributed variable X. Okay, it's standardized because we shift the This is a formula to standardize any regular normal distribution family member to a standardized normal distribution, or to a standard normal distribution. Z is called standard normal distribution, and X is any random any normal distribution member. It's somewhat like Z is a special member in a family, and the X are Z's brothers. And because they all have the same DNA from their parents, then you can easily, through some cosmetic surgery, then they will look similar. Okay, and that's probably helpful in understanding their relationship here. Okay, so with that, with this, we further explain what is the standardization process. So you have these different members on top. Okay, these different color of normal distribution are 3 different members in the normal distribution family. But through the standardizing, you can standardize them to normal distribution family, standard normal distribution. Okay, by deducting X by -2 and divide by its standard deviation, you get the Z here. So all these 3 can be standardized to the standard normal distribution. Okay, this one below is standard normal distribution, but this process is called standardizing. Okay, all right. So what does that mean? That means if you are to calculate the area under a regular normal curve with the center as mu, standard deviation as sigma, then you should calculate the area shaded here, green. But equivalently, through standardizing of this formula here, is equivalent to calculating the area under this interval. Okay, so A under this interval. Okay, and you can see that if I plug A into X, it becomes A minus mu over sigma, A minus mu over sigma. So A corresponds to this lower bound, A corresponds to lower bound A minus mu over sigma. Then the same way, if you plug in mu in here, mu minus mu is 0. So 0 over sigma is 0. And then you plug in B in here, it's B minus mu over sigma. So this section, this interval is equal to this interval. Okay. So now we are, and this is to use the table, but I will suggest a better way to do it, which is to Excel and to stat disk. Okay. Let me open my stat disk. Okay. I suggest that you can use a stat disk. A stat disk is, I don't mean it's very powerful or the best. No, it's just convenient. Okay, very handy. And so if you want, you can download it from statdisk.org. Okay, let me see if you, how do I check? Yeah, StatDisk. Okay, you can download a copy for yourself, or just use the online version. I prefer to download it here, so you can see. Now, in order to calculate the area under the curve, so let's take a look All right. First, oh, sorry. Okay. First, let's take a look at this. Now we introduce this notation showing z with a subscript 0.025 or 0.05 in the subscript. And so what does that mean is this z value is that subscript means the area to the right has the number in the subscript area. The area to the right of this z, which has 0.025, has area to its right 0.025. All right, so the subscript is the area to the right of this value. All right, this value is a question mark. We don't know what's that, but the area 0.0252 to it is 0.025. Yeah, okay. So so similarly, if it has 0.05, that means the area to the right of this value at 0.05. And so to the right is 0.025 means to the left is 0.975, and similarly here. Okay, so how do we calculate this value? We can calculate this by using StatDisk, and then you click on analysis, and you see probability distribution using normal distribution. And then you can type. First, if you know the z, then you type in the z, but we don't know z here. However, we know the cumulative area from the left. Why? Because we know cumulative area, we know the area to the right is 0.025. So the area to the left must be what? 1 minus 0.025 is 0.975. So you plug in 0.975 here, and you will see 1.96. You see the top value right here, 1.9599 is 1.96, and that's why you get this value 1.96. And but then you will say, we just talked about we calculated probability. Yes. So how do we calculate the probability? Okay. So let's reverse this question. Suppose now we don't know the area to the left is 0.075 or okay. Suppose we don't have the subscript 0.025 to denote the area to the right. So what can you do to calculate area? Let's just do, you can just plug in 1.96 and then click evaluate, and you will calculate probability for you. So with the area z 1.96, the area to the left is right here, 0.975. The area to the right is 0.025. You see? You see? So I call it forward or backward. When you know the area, okay, to the right or to the left, when you just know one, you know the other. Either one is fine. And you will be able to calculate the value. And this is called forward. And if you don't know the value, you use the probability, and you can calculate the value. This is called backward. So with this, you know, you can calculate the probability or the value into, you know, one way or the other. Okay, so with that, we can come and look at the question. Let me see if we have exponential function. Okay, we don't have exponential function here. That's okay. Now let's come to cover the question. Okay, this question is easy because it says The area under a particular normal curve between 10 and 14 is 0.09115. So that means the area is between an interval under the curve. But it didn't say, oh yeah, a normal distribution. Okay, so it's just like here, like this one, maybe, for example, or maybe like this one, and not this one because this is standard normal. So like this one. So between 10 and 14. So with that, how do you get the 10 and 14? And so what percentage all possible observations of variable lie between 10 and 14? So it's just 0.9, it's just 0.991 times 100, okay, because it's as a percent. Okay, normal distribution, with which normal distribution is the standard normal curve associated? Okay, this is easy. It's a concept question. I will leave it to you. Okay, find the area under the standard normal curve that lie between the specified z score. Okay, so this is to find the area within 1 standard deviation to either side of the center, 2 standard deviation to either side of the center, 3 standard deviation to either side of center in the standard normal distribution. So it's just like this one, but only that's symmetric to the center. What make it easy for this one is because it's symmetric to the center. So statistics can do a very good job for you if you just plug in what? For example, I plug in 1. It tells you the central area, central, because it's symmetric. That means when you plug 1, you calculate the area to the left of the 1 for you, okay, which is 0.8413, and then right is 0.158. So to find the central area, you have to find the lower tail, but the lower tail is equal to the upper tail, which is the right here. So you can calculate the central area by doing 1 minus 2 times the tail area. Okay, you will get this value. Or the left tail minus the left tail to the left of 1 minus the left tail, which is also equal to the right tail. So which is the difference of these two numbers. Okay, so anyway, you got it. Okay, a variable normal distribution mean 6 and standard deviation 2. Okay, find the percentage of all possible values of a variable lie between 3 and 10. So okay, mu is 6, sigma is 2, lie between what? 3 and 10. Okay, so that is this question. You can okay, you plug in, A is what? 3 and 10. So A is 3, B is 10. And then what? Mu is 6, sigma is 2. So you can plug in here, or plug in all the numbers here, and then what? Use statistics twice. You plug this number, you calculate this value, find area to the left, and then calculate this value, find the area to the left, and calculate the difference of the two left areas. The area to the left of this value you plug, okay, first you plug this value into stat disk. Okay, whatever that is. 10 minus what? 10 minus 6 over 2. 10 minus 6 over 2 is 2. So you plug in 2 in here. You plug in 2 here, and then you find area to the left, which is this one. Then you calculate the other value, let's say is 1, and find area to the left. And then find the difference of these two left area will be the answer. That's okay. That's easy. So on and so forth. You should be able to see it. Okay. If it's less than, if it's left. If it's greater than, it's right. Okay. Okay. A variable x denoted binomial variable with n and p indicate that which area under the appropriate normal curve would be determined to approximate a given binomial probability. Okay, let me use an example to illustrate. So here you are to calculate 13. Okay, 13. So what shall you do? N is what? N is you have NP, and N is NP, which area under normal curve be determined by the given normal distribution. Okay. Oh yeah, this is just to test your knowledge of the adjusting factor. Okay, you need an adjusting factor by plus 0.5, subtract 0.5 on either side. The reason why this is added or subtracted because when you impose a curve on the bar, the half of the area will be cut off. Okay, you see, if you don't add up 0.5, the probability will start to count from 8 and lower. So you will miss out this part. So you have to extend it, make it higher. Make it higher. For upper bound, you make it higher. Similarly, for lower bound, if you don't make it smaller, you will also miss this part. For example, if the lower bound is 2. So in order to approximate the probability better, you need to adjusting factor, okay, to make up the differences. Okay, well, so that's it. So for upper bound, you do what? Plus 0.5. Okay. This is manager of a local soft drink bottling company believed that when a new beverage dispensing machine is to dispense 22 ounces, it in fact dispenses an amount X at random anywhere between 21.1 and 22.9 inclusive. That means equal, less than or equal to 21.9 and greater than or equal to 21.2. Uniform probability distribution. Okay, we are talking about uniform distribution. So uniform distribution is a continuous continuous probability distribution. You can think of it as drawing a rectangle. Let me draw it. Okay, so you draw a rectangle. 1 second. Okay, so you draw a rectangle, and this is X, and so you have draw between 21.1, 22.9. X can be anywhere between this and these two values, but not outside. Okay, only inside. Okay. And this is obviously not discrete because it can take on any value between these two values. Yeah, no, not greater, not less than. So this is, yeah, this is really clear. Okay. The optimal scheduling of preventive maintenance tests of an independent operating is components is developed. The time between failure of a component is approximated by exponentially distributed random variable with the mean theta. Okay, so with mean theta, this is what? This is an exponential distribution question. So what is exponential function? Exponential function is exponential function goes like this exponential function. Okay, this is the exponential function starting with 0. Normal distribution starting from the negative infinity goes to positive infinity. Exponential function goes from 0 to positive infinity. Okay, and so to find the time between component failures range from these is probably, suppose this is 1300 hours, this 1700 hours. So what's this area? Okay, given theta equal to 1000. So this version of exponential function should be like this: 1 over e to the this is a PDF function. Okay, so in order to find this area, you simply integration. If you, these are the notation for calculus, but okay, but you don't have to do the calculus. That we can use Excel to do the job for you. Okay. So using Excel, because we don't have the function in StatDisk, then you say, can we use Excel to calculate the Z question previously? Yes, you can. Only StatDisk do more straightforward. Okay. Anyway, excuse me. So you go equal. Exponential distribution. Choose exponent. Okay, you click on that one. Then you will see the prompts underneath here. Okay, this means that you want to find the cumulative probability. Okay, so here you have cumulative. If cumulative is true, you click on 1. Otherwise, it's 0. So the first value is how much? Well, 1300. But be careful that this lambda is, we have two versions of for exponential function. The other version is the rate version. So you go rate version. Okay, and rate is the inverse of mean. Okay, rate means kind of like speed. In theta is mean is how long. Okay, so it theta means how it takes 1300 hours for one to happen. So so if you take the inverse, that means for every for one, the speed that means 0.001 hours per hours. Each hour you have 0.001 failure. Okay, equivalently to say. Okay, so you have to put 1 over lambda and then cumulative. Okay, so you do that for 1300 and you do that for 1900 and find the difference. Okay, under the area on the result on the 1900 will be greater, and then you find the difference will be the answer. This is an exponential function, and I'll leave the rest of them to you. This one, calculate the IQR. IQR is interquartile range, and then divided by S. These are just these are pretty straightforward. Okay, I'll leave it to you to calculate. IQR is interquartile range is upper third quartile minus the first quartile. And the random variable X is best described by a uniform probability distribution with mean 60 and standard deviation 6. Find C and D. Okay, C and D, there are two parameters. Okay, for this you can, let me see, I don't think I have, let me see. Yeah, I don't have a, okay, that's uniform. Okay, so a uniform distribution. All right. Instead of C and D, we use A and B. Just different notation. Not a big deal. Okay, and so you check. It says mean is this. If you know A and B, then do A plus B divide that by 2 will be the mean. And you also know the what? You also know the oh, what? Oh, it's gone. Oh, right here. And the standard deviation. So let's look for standard deviation. Variance. Okay, you have variance here. So standard deviation is the square root of this. So you just do what? What you need to do is to solve the equation that says okay, you should just do you should just do this. Let me say this one first. Yeah. Okay. Oh. So here, okay, you just do, let's change it to C and D. So C plus D is, C plus D is what? Mean 60. And then what? We just saw that square root and D minus C is 6. So you solve the equation and you will get solution, and that's C and D. Okay, I think this is pretty complete. Okay. Okay, let's see. Yeah, not very easy. I made the assignments very easy and doable. Okay, let me see. I think we can wrap up our meeting here, unless you have any other questions. Do you have any questions?
I'm still unable to access the homework from last week. It says it's locked again.
Okay. You mean assignment 4?
Yes. Yeah.
Okay. Okay. I will check right away and yeah, make sure you
Thank
can
you.
access. I don't know why, but it should be, yeah. And then if you still can, then just send me an email. I will. Yeah, it should be fixed. Okay. If not, then
Okay. Thank you.
with that. Okay. Any other questions about the materials today?
Nope. Nope. I'm good.
Okay. Okay.
Thank you.
Good. All right. Very good. Okay. Take good care. Have a enjoy a weekend. And then enjoy the week 5 material study, and then we'll move on from here. Okay.
Okay. Thank you.
Okay. Good. All right. See you. Have a nice weekend. All right. Bye.